Welcome back to our next lesson, chapter 8, rates and equilibrium. You know, we're just talking about the rates section so far. So we'll be talking about the rates of reaction and how we change the rate or the speed of a reaction. To recap what we said before, it's in this. Reactions occur when, what have we said? What do the particles have to do? Reactions occur when particles collide with enough energy. I'm going to show you this picture again because I know it's very popular. We've got these particles colliding. Okay. Now, the previous two lessons we've talked about how we can make more frequent collisions. So if we increase the surface area to volume ratio, there will be more frequent collisions. If we increase the concentration or the pressure, there will be more frequent collisions. What we haven't mentioned in any of the previous lessons is how we can get the particles to collide with even more energy. Because if we had the particles colliding with more energy, then more of them would be successful. So, what's this lesson going to be about? What are we going to do in a reaction to make the particles collide with more energy? What are we going to change? That's right, we're going to change the temperature. So, you'll need some line paper. This lesson, you put the title, Temperature. The objective is to explain the effect of temperature on the rate of a reaction. You're going to write that down. Now, I know that you already know what would happen to the speed of a reaction if we increase the temperature. You might not know the reasons why, but I know you know what would happen. The higher the temperature, the faster the rate of a reaction. You're going to write that down. But I think you knew that anyway. The higher the temperature, the faster the rate of a reaction. Now, can you give an example of a reaction that happens faster at a higher temperature? There's countless examples. Even when we talk about dissolving sugar in water, we know that it would dissolve faster in hot water. If we were doing a reaction with acid, we'd know that if we heated up the acid, we would expect the reaction to be faster. What about in that last topic we were talking about batteries? Inside a battery there's a chemical reaction happening. Okay, you remember that? So imagine in your TV remote control there's a battery. If the battery stops working, what some people do, they take the battery out and they rub the battery in their hands, in the palm of their hands. Why do they do that? Not because they're mad. Why do they rub the battery in the palm of their hands when it's just stopped working? That warms the battery up. Why would they want to do that? Why would that help? If they can warm the battery up, warm the chemicals up inside the battery, maybe the reaction would start happening just a little bit faster. And therefore it will start to work again. That's an example, a good example I think, but I'm biased, where the higher the temperature, the faster the rate of a reaction. And there's so many others. We're going to draw the two pictures that we've drawn a few times before. We've got the particles at a low temperature and the particles at a higher temperature. Now what you'll notice, at low temperature or high temperature, what hasn't changed? The number of particles. We're not making more particles now. But at high temperature, what's the difference with these particles? Sometimes, you'll like this, I like to put my little vibration marks on the ones. I know the ones at a low temperature would still be moving as well, but at a higher temperature, the particles have got more energy and they are moving faster. Okay? At a higher temperature, the particles have got more energy to move faster. So what? What would be a consequence of the particles having more energy and moving faster? Think about the line we've used that always explains why the reaction would then be faster. There are going to be more frequent successful collisions. So these particles are going to collide more often because they are moving faster. If we increase the temperature, they're moving faster, they've got more energy, they're going to collide more often. so the reaction will be faster. But one other thing, think about what we've talked about reactions. What do particles have to have for the collision to be successful? What do we call the energy, the amount of energy that they need, the minimum amount of energy they need for a collision to be successful? Call it the activation energy. If we increase the temperature, more particles are going to have the activation energy. So more of the collisions will have the activation energy. So if we increase the temperature, the particles have more energy and move faster. There are more frequent collisions, and more of the collisions have the activation energy. That's why more of them are successful. This is the first time we've mentioned energy in terms of rates of reaction, and only when we change the temperature will we say the particles have got more energy. Don't get confused and mention energy with concentration or surface area or pressure. Only when we talk about raising the temperature do we say the particles have got more energy. Now you're going to be sent a document. There's going to be another graph. I'm getting lots of positive comments about the graphs. You love the graphs. So there'll be another graph to draw. Time against volume. This is a graph of magnesium reacting with hydrochloric acid and making hydrogen. You're going to plot 3 lines on the same graph again at 3 different temperatures, and you'll answer the questions on the graph and on the sheet that you've been provided. What I would also do, you could practice drawing a tangent at different points on one of the lines to show how the rate of the reaction changes as the reaction proceeds. So, just to recap, the higher the temperature, the faster the rate of reaction. I think we knew that anyway, but we now have to know why a higher temperature's got a faster rate. So the particles have more energy and move faster. There are more frequent successful collisions. Why are there more successful collisions? Because more collisions have the activation energy. Hope that makes sense. Any questions? Ask your own teacher. And I'll speak to you shortly. Thank you very much.